Hi friends, welcome to all. In this video, we are going to configure IPv4 static route using a nexthop address. Before coming to this lab, friends, if you wish to get these type of technical videos, consider subscribing. And also, if you wish to get any technical support, you can contact our team. All the details given in the description below. Right, coming back to the lab. First of all, we will design the topology. We will have two routers, 4331 routers, then two switches, 2960 series, then two PCs. We will rename these devices as R1, S1, this is PC1, here we have R2, S2 and PC2. We will connect all these devices. Coming to connections, we will choose copper straight through. From R1 G0/0/0 to R2 G0/0/0. From R1 G0/0/1 to S1 G0/1. Then from R2 G0/0/1 to S2 G0/1. Then we will connect to PCs to the switch. In this topology, we can see total 3 networks. So I will highlight those networks with different colors. So here we can see one network. Here we can see one network. And between routers, we have one network. So we have a total 3 networks in this topology. So here we have 3 networks. Consider this is network 1, and we will use 192.168.1.0/24 as its network address. Then this is network 2. Here we will use 10.1.1.0/30. Here we required only 2 addresses. And this is network 3. We will use 192.168.2.0/24. Here we will specify the IP address for each devices. For this PC1, we will assign 192.168.1.1. Then for this interface G0/0/1, which is connected to this network 1, that is this local area network, we will give the IP address 192.168.1.1. So here we will give 1.10 for this PC1 better. And we will use the first usable IP address for this interface G0/0/1, that is .1. Okay. So here we will give 10th usable IP address. Then for this network 2, here we will assign 10.1.1.1. So we will give .1 here. Then in the other side, we will give .2. That is 10.1.1.2. Then coming to network 3, this interface G0/0/1, gateway for all these devices. We will provide 192.168.2.1, and for this PC we will give 2.10. In this activity, we are not going to assign any IP address for these switches. If needed, we can assign, but anyway, we are focusing on the static route. Hence, we are not going to assign the IP address. Now we will start the configuration. We will start from PC1, desktop IP configuration, and we will give the IPv4 address 192.168.1.10, and the default gateway will be the IP address of this interface G0/0/1, that is 192.168.1.1. Then we will configure this PC2 also. Then we will go to each routers. 192.168.2.10, and the default gateway is 192.168.2.1. Now we will configure these routers R1 and R2. First we will configure this router R1. Coming to R1, would you like to enter the initial configuration dialog? No. Enable configure terminal. We will set the host name. Also we will give a no IP domain lookup. Now we will configure the interface IP address. So first of all, we will go to the LAN interface, that is interface G0/0/1, this interface. So we are going to set this IP address 192.168.1.1. IP address 192.168.1.1. Then we need to specify the subnet to mask. Then activate this interface. Then we will configure this interface G0/0/0, which is connected to R2, network 2. We will set the IP address 10.1.1.1, and the subnet mask we given /30, so it comes to 52. No shutdown. Right. Here we can see this network 2 is still down because we configured only one side in this router R1. We need to configure the other side also on R2. So we will configure now on R2. First of all, we will configure this interface G0/0/1 LAN network. The address is 192.168.2.1. Initial configuration dialog, no. Enable configure terminal. Then we will set the host name. No IP domain lookup. We are not doing all the basic settings because here we focus on static route. Now we will go to interface G0/0/1. We will set the IP address for this interface. IP address 192.168.2.1 with the subnet to mask. Then now shutdown. We can see this interface is activated. Now we will configure this interface G0/0/0, which is connected to R1. We will go to interface G0/0/0, and we will set the next usable IP address from the network address we given. IP address 10.1.1.2. Then subnet to mask. Activate this interface. Perfect. So we just configured all the interfaces in these routers and end devices PC1 and PC2. Now we just verify the configuration. Coming to R1, end, copy run space start. I'm going to give a show IP interface brief, and we can see the addresses we configured, interface status. Good. Now we can see this router R1 is aware of these two networks, that is network 1 and network 2, and network 3 is a remote network for this router R1. It is an unknown network for the router R1. In the same way, for this router R2 is aware of network 2 and network 3, but he is not aware of network 1. It is a remote network. We can see that using show command, show IP route connected, so that we can see the connected network. So we have two connected networks. So what I will do, I will give only show IP route. So we can see only two network here, that is network 1 and network 2. This is network 1, 192.168.1.0. The network 2 is 10.1.1.0. We cannot see network 3 here because it is a remote network. We are going to configure as static route. So we will do that. And here we can see this L is for the link local. It shows, it gives the IP address of the interface we configured. The same way, just we will verify in this router R2 also. Just I copied from RAM to NVRAM. Now show IP interface brief. Show IP interface brief. We can see the addresses we configured. Show IP route connected. We can see all the connected route in the routing table. We have two connected networks, that is network 2 and network 3. So just we will see show IP route, so that we can see the entire routing table. We have only two networks, that is N2 and N3. N1 is not available. We can see it's 2.0 and 10.1.1.0. 192.168.1.0 is not available because it is a remote network for this R2. So we need to configure either static or dynamic. Here in this experiment, in this lab, we are going to configure the static route. So here we configured all the IP addresses on these routers and PCs, but this PC1 will not communicate to the PC2. As I mentioned, this R1 is aware of only these two networks, network 1 and network 2, and R2 is aware of network 2 and network 3. So the packet will not reach up to PC2. So we can test it. If you go to PC1 command prompt, we can ping to 192.168. The IP address of PC2 is 2.10. So we can see that the ping result gives a reply from 192.168.1.1 destination host unreachable. So request timed out. We can see packet sent 4 but received 0, 100% loss. Yes. So we are going to configure the static route, then we will test the connectivity. First of all, we will configure on this router R1. We are going to configure static route using nexthop address. So we are going to configure this remote network, network 3 on this router R1. So the nexthop address obviously will be the address of this interface G0/0/0 in this router R2. We can see it is connected to this router R2, and through this router we should go to network 3. So the nexthop address for this network 3 in this router R1 is G0, the IP address of G0/0/0. So we will see how to configure this IP route. We must specify the network address of the remote network, then to mask, then nexthop address. So that is a syntax we need to give. or we are going to configure that here in this router R1 in the global configuration mode. So configure terminal. So here we are going to give the command IP route. The command is IP route and the unknown network, that is 192.168.2.0. We are not specifying any IP address. We are specifying the network address. For the network 3, we given 192.168.2.0. Then subnet mask, we given /24. The subnet mask is 255.255.255.0. Then we are going to specify the next hop address. So here I am going to put a question mark, and we can see even we can specify the exit interface. So that practical, that lab we will see in the next video, how to configure static route using exit interface. So all these concepts we show in different videos, so that it will be more easy for you to understand what is static route using next hop, what is static route using exit interface, right? What is a floating route? So all this will be in different labs, but ultimately we will do all these concepts in one lab also. Anyway, those videos are coming soon. Stay connected. So now we are going to give here a next hop address. We can see that they given here ABCD IP address. So forwarding router's address. So we are going to specify the IP address of the forwarding router. So that is the IP address of this interface G0/0/0. That is 10.1.1.2. We are going to specify that 10.1.1.2. Right. So we configured static route using next hop in this router R1. Now we can see this router is aware of this network also. So these two are connected network 1 and network 2. The network 3 we configured manually. So that is a static route. We can verify that. I will give end here. Copy run space start, and I am going to give a show IP route. We are going to see the routing table. And here we can see two connected network. This is network 2, this is network 1. And here we can see that static route our network 3, which is added in the routing table 192.168.2.0. So here we can see the administrative distance and the metrics, and it goes through 10.1.1.2 via, right? It goes through R2. Now PC, we cannot still communicate from PC1 to PC2 because R1 is aware of network 3, but R2 is not aware of network 1. The acknowledgement should come back from PC to PC1. The message will go from PC1 to PC2, but from PC2 to PC1 will not send. So we need to configure the R2 also, so that the entire network will be converged. Perfect. Now we are going to configure R2 in the global configuration mode. We are going to configure static route for this remote network 192.168.1.0. R2 is not aware of this network 1, and we are going to configure using next hop address. The forwarding router will be the IP address of this interface G0/0/0 will be the next hop address, that is 10.1.1.1. Command is IP route. Then we must specify the network address 192.168.1.0. Then submit to mask. Then we need to specify the next hop address, that is 10.1.1.1. Perfect. Now we will exit, copy run space start. We will go to show IP route routing table. There we can see two connected network. This is network 2, and here we can see network 3, and here we added network 1 as a static route via router 1 next hop address. So 192.168.1.0. all the entries are there in the routing table. Now we can say this topology is fully converged. We have a total 3 network. In that, R1 is aware of all 3 networks. R2 is also aware of all 3 networks. So we can say this network is fully converged, right? Now we should be able to ping from PC1 to PC2. We will test the connectivity. Click on PC1, command prompt. We are going to ping to PC2, that is 2.10, ping 192.168.2.10. Initially, we may get one request timed out. Don't worry about that. Yeah, 1 or 2 request timed out. Yes, we get the replies. So we sent 4 packets, but we received only 2. That means 2 lost. So initially there will be a delay because of ARP. So we can see 50% loss. But next time again, if you ping, we will get 0% loss, right? So I'll press up arrow from the keyboard. We can see 192.168.2.10 and we get the replies. Now we can communicate to all the devices. For example, I will start from self ping, that is 1.10. We ping from PC1 to PC1. It works. Then at the default gateway 1.1. Then we will ping to the default gateway of our network 3, that is 2.1. Okay. Then we already ping to PC2. Perfect. So that's all in this video, that is configure static route using nexthop address. Next lab we will see how to configure static route using exit interface. We may be using the same topology with a different IP address. So stay tuned for that video. Now friends, if you get any doubt in this video, you can contact us, or if you wish to get any technical support, you can contact our team. All the details given in the description below. Stay connected. We will meet in the next video. Thank you.